Today, we're diving deep into DeepSeek R1, one of the most revolutionary AI models of 2025. We'll talk about the secrets and techniques that makes it special. How is it able to achieve 10 to 30 times more efficiency than OpenAI's model while maintaining the same level of intelligence? So stay tuned as I explain the key ingredients to its success in the next 5 minutes. In January 2025, a Chinese AI company called DeepSeek dropped DeepSeek R1, and it completely shook the community. It outperformed OpenAI's latest model that caused an economic shock so big that Nvidia's lost about $600 billion in value. To put that in perspective, that's more than the GDP of the entire Philippines. How did they do it? Well, DeepSeek R1 wasn't built overnight. The team used several groundbreaking techniques, starting with quantization, mixture of experts, multi-latent head attention, GRPO, and of course its reasoning approach. Some of these techniques date back to the previous model like DeepSeek V3 and even earlier. So it really takes a series of disciplined research, model evaluation, and optimization techniques to get the AI to where it is now. First, let's talk about quantization. DeepSeek R1 reduces the precision of its neural network weights from 32-bit floating points to 8-bit using techniques inspired by the Q-LoRa paper. The result? The model runs significantly faster while only losing a fraction of accuracy. Quantization techniques can reduce precision down to 1/4 its original size and yet retain 99% of the original performance. This drastically reduces the computational load while making the AI more efficient without sacrificing intelligence. Next up is mixture of experts or MoE. With MoE, the team is able to activate only partial areas of the network. Instead of running all parameters at once, it selectively activates only 5% of the entire network, focusing on the most relevant parts. This means less computation, lower cost, and yet still good performance. Another technique is called the Multi-Latent Attention or MLA. Traditional attention mechanisms store large key-value caches which bloats the memory, but DeepSeek R1 uses low-rank joint compression technique that significantly reduces the memory storage. MLA compresses attention keys and values into smaller latent spaces before projecting them back up for inference. This allows a much more efficient KV cache while keeping the model performance intact. Now let's talk about training and reinforcement learning. Most AI models use a big critic model, like having a project manager to evaluate outputs and correct them when needed. But DeepSeek R1 does something different. It uses GRPO, or Group Relative Policy Optimization. Instead of having one giant critic model, it trains multiple smaller models like a group of developers debating and finding the best answer. Turns out, this collective decision-making improves accuracy than just one big critic model. Now, DeepSeek R1 isn't just efficient, it's also an amazing reasoning model. Inspired by Google's Chain of Thought paper, the model is trained to think step by step before giving an answer. When faced with a complex questions, it first generates logical breakdown inside special think tags, refining its thought process before arriving at a final response. How did they train the model to reason? Well, they started teaching the model to answer math and programming questions. Researchers have found that AI models trained on math and programming problems can generalize its reasoning ability across other fields. Here's the best part. Over time, it learned to begin self-evaluating, double-checking its own logic naturally without being explicitly told to do so. This self-improvement loop makes DeepSeek R1 an incredibly powerful reasoning tool. Now, to make the response more understandable, they combine the reasoning data with knowledge data, which is more human-readable, to produce the final output. The result is a smarter reasoning model that can converse like a human. Lastly, they apply the same post-training technique to other models like Llama and Qwen, and it also achieves significant improvements. So what does this all mean? Well, DeepSeek R1 proves that open source AI can compete and even surpass closed source models like OpenAI. With these efficiency techniques, we're looking at powerful AI models that can run on smaller, cheaper devices, including on-premise solutions for small businesses. The AI landscape is evolving fast, and DeepSeek is leading the charge. What do you think? Could this model shape the future of AI? Let me know your thoughts in the comments, and don't forget to click like, subscribe, and hit the bell button for more AI insights. Thank you for watching another episode of Artificially Intelligent!